Hey, welcome to today's video. In today's video, I'm going to give you a crash course in SQL for data analysts. This is going to be all of the SQL that you really need to know, and we're going to avoid some of the more complicated concepts that can derail you. SQL is how we interact with data warehouses, and once you've used it, you'll find that it unlocks a whole new way of building your own data pipelines and really improving the speed to market of your work. You can access a lot more information using SQL than you can through Excel, and it's pretty straightforward too, especially the bits that we're going to cover today. So let's get started. So SQL stands for Structured Query Language, and it's a language that was developed in the 1970s as a way for us to talk to different databases. You can think of a database as a bunch of Excel worksheets with tons of rows and columns of data. And we want to access those using a query language because all of the data is stored on different sheets and we need to be able to combine it into one place in order to do our analysis. And because there's so much data that we wouldn't be able to pull it up on the screen and make any sense of it. We'll access the data warehouse using a client. Now that can be an application that you run on your computer, or it can be something that you run through a web browser. What will happen is you'll connect that client to the data warehouse, you will run your SQL code, it will return the data either to the application or to your browser, and you can download that data and use it elsewhere, or you can do your analysis right there in the program using SQL. Now, SQL is not quite a standard language, so depending on the database that you're working with, there may be slight differences between some of the languages. This is called a different SQL dialect, and what you'll find is that there'll be a reference specific to your data warehouse, so it's important to know the type of data warehouse that you're working with. In the examples that we go through here, we're going to use something called Transact SQL, because that's the dialect that works with the Stack Overflow database that we're going to be using as an example. And since we're talking about examples, why don't we go ahead and take a look at the practice environment. If you've ever programmed before, you're probably pretty familiar with Stack Overflow, and if you haven't programmed before, you're about to get pretty familiar with Stack Overflow. It is the place to go to get all of your programming questions answered. There is a ton of knowledge on this site, but one of the other cool things is that you can access the database behind the website using SQL. If you go to data.stackexchange.com, you get this list of all of the Stack Overflow and Stack Overflow related sites that you can access, and if you click on Compose Query up here, you get this view where you can type in a SQL query that will query their database, and they have a list of tables over here. The results will appear down at the bottom. I do recommend, if you're going to be using this all the time, that you go ahead and create an account. I've created one up here. It doesn't require anything except an email address, so it's pretty easy, and it'll take away a little checkbox down at the bottom that you'll have to click every time you run a query otherwise that says, "Are you a robot?" All right, I think we're ready now to jump into our first query. The select statement is the basic building block of SQL. We're going to select some columns from a table. If you look at the example table up on the right-hand side, we have an orders table with the order ID, the product ID, the customer ID, and the number. If we run the select query below against it, so select order ID, product ID from orders, then we get the order ID column and the product ID column, and we're missing the number column and the customer ID column. This is the basic building block of SQL. Let's go ahead and see how it works in practice. For this one, I've chosen a table that doesn't have too many rows. It's this tags table, and it's very easy for us to write our first query. We're just going to write select star from tags, and then we're going to put a semicolon after it to tell the database that is the end of our query. Now this star is really just an alias to say I want to select all of the columns in the table. If we wanted to select specific columns, we could put ID and tag name, but I'm going to select all of them for now. Let's run this query and see what it returns. Sometimes this can take a minute, that's why I picked a smaller table, but you can see down here in our results, we have all of the tags in about 50,000 rows. So maybe not quite all of the 50,000, all of the tags, but about 50,000 rows worth of tags in this list. And that is our very first straightforward query. The very first thing that we're going to add to our basic select statement is a where clause. A where clause limits the number of rows that you get back because we're only going to select those rows that meet a certain condition. In the example here, you can see that we have a table with 4 different orders in it. But when we look for only the orders where the product ID equals 101, what we actually get returned is only a single row because only one of the rows in the table has a product ID of 101. Let's take a look at how that works in practice. All right, let's go ahead and add a where statement to our query here. I'm going to drop this from down a line, then I'm going to type where in here, and let's scroll down to our results and just identify a column that we want to use. Now, this ID column could be a good one. We could use count. We could use the tag name, of course. One of the things to remember is that whatever data type you use in your where clause has to also match the data type in the table. So if we were going to use this ID column, we would want to use a number. Why don't we go ahead and do that? Let's say we want to only select those where the ID is greater than 85,000. Let's run that and see what happens. And down here, you can see that now the only ID values we have are ones that are greater than 85,000. We have different tag names, different counts, and everything else. And that is how you use a very simple where statement. In the 2 examples we've looked at so far, we've used 2 different where operators, but there are a bunch more that you can use as well. Not only equals and greater than, but you can use greater than or equal to, less than or equal to, A is not equal to B, A in, and then we give it a list of values. We can use like, which looks for a pattern between the 2 values, and we can use between, which looks for whether the value of A is between 2 different values. These operators give you a lot of flexibility when it comes to how you filter your data. All right, let's jump into our next example. The next thing that we're going to do is use what's called an aggregate function. An aggregate function does something to aggregate all of the numbers in a particular column. So we could sum them up, we could look at the maximum, the minimum, the average, all that sort of thing. And we can do that in one of 2 ways. We can either do it for the whole column, or we can use a group by to do it for particular items within a different column. In the example that we're looking at here on the bottom, you can see that we sum up all of our number column by the product ID. So we have the total number sold for each product ID. To do that, we include the product ID column, we wrap our number column in a sum function, we give that column a name, so as number, and then we group it by the product ID column. You can see in the table on the right-hand side that instead of 4 rows, we have 3 rows, 1 row for each product ID, and the 2 rows in the top table under product ID 101 have been combined into a single row in the bottom table. And the 2 numbers, the number sold, have been summed up. So instead of a 4 and a 1 on 2 different lines, we have a 5 on a single line. Let's take a look at how this works in practice. For this aggregate function example, I've switched us to a different table in the Stack Exchange database and written a basic query that we can use to start with. We're using this posts table, which is one of the first ones that you can see. And right now we're just selecting everything from posts where the owner user ID is 42. So we're looking at one user's list of posts, and they have 226 different posts. What we're going to do is we're going to aggregate this by the score, and we're going to see for each score, what's the number of posts that they have. Very easy to do. So instead of our star up here, we're going to select the score column, and then we're going to count star, which is just count the number of rows, which will be the number of posts, since each row is an individual post. And then we're going to give this a name. We want to call this as post count. And then underneath our where clause, we're going to use a group by to group by score. So just to run through the logic of this query again, we're going to select the score column, and then we're going to count all of the posts, and we're going to call it the post count. We're going to do a group by the score column, which means that the score column is going to stay the same, and we're going to count within every item in the score column how many posts there were. Let's go ahead and run this. All right, you can see down here that we have the score and the number of posts that fell within each post count. So we have 0, 44, 1, 49, score of 2, 31 posts, and so on, all the way up to 523, which is the maximum score, and -5, which is the minimum score. So far, we've shown two examples of different aggregate functions. There's the sum function that we used in the example, and then there's the count function that we used in the Stack Overflow database. You can also use a minimum and a maximum. There's also an average function, and some databases have even more functions than these. Note that different databases will sometimes call these different things, particularly average. Sometimes that can be mean. Sometimes you have to type out average. So it's worth getting to know your database so that you know which aggregate functions are available. As your queries get more complicated, you'll want to add comments to the code. To do this, you just put 2 dashes in front of a line, and then you can type whatever you want, and that code won't be executed. Oftentimes in the editor, it will turn a different color. There's 2 reasons you can use this. The first one is to explain the logic of a query. The second one is to take items in and out of a query. For example, filters in a where statement, if you don't want them to execute for this particular run. Let's go ahead and add a comment to our aggregation example here. What I'm going to do is I'm going to select in front of the first line here. I'm just going to move that down a couple of lines. I'm going to move back up. I'm going to add my 2 dashes, and I'm going to write, this is a comment. Now, we can add the logic in here, so we could add a description of what this does. This query selects the count of posts and aggregates by the score of the posts. You can see that we have to add the dashes on every line. You can also add a comment by adding a slash and then a star. Longer comment on multiple lines. And then you just close it off by putting the star and the slash together. Now these lines in green won't be executed when we execute the query, but they do provide some context for what's happening. So if you have any wacky logic or anything that looks particularly complicated, you can put these comments anywhere to explain that so that the next time you come back to read your code, it makes a lot more sense to you. So far, all of the data that we've needed has been in the same table, but what happens when that data is spread across several different tables? Well, what we're going to do is we're going to use something called a join to combine those tables so that we can get the information that we need. There are 4 types of joins. There's an inner join, a full join, a left join, and a right join. Let's walk through each type and how they work. The first join type that we'll talk about is what's called an inner join. Now, we always have 2 tables as part of a join. We have a left table and a right table. And what we'll do is we'll illustrate with these circle graphics, this sort of Venn diagram, what data is included when we join those 2 tables together with each join type. For an inner join, any rows in the left table that have a corresponding row in the right table are what we're going to be including in our join. Any rows that don't have a matching row, either from the left or the right table, are going to be left out. Let's take a look at what that looks like. In this example, we joined the left and the right table using the product ID column. You can see that we have a row in the final table for product ID 101, 102, and 103, but we don't have a row for product ID 106 or product ID 104. The reason those don't exist in the final table is because product ID 106 only has a line in the left table and no corresponding row in the right table, and product 104 only has a row in the right table but no corresponding row in the left table. The next join type is a left join. A left join takes all of the rows in the left table and joins any corresponding rows in the right table. Now this will include everything in the left table, but not include everything in the right table. When we look at how this works in practice, as we do here, you can see that now we have a row for product ID 106 because product ID 106 exists in the left table but doesn't exist in the right table. In the final table, the 2 columns that we're getting from the right table, product name and price, are both blank for product ID 106, but product ID 106 is included in the final table and does have a row. A right join works the same way as a left join, except that all rows from the right table are included, and any corresponding rows in the left table that don't have a row in the right table are not included. Now you can see that product ID 104 is included in the final table because it has a row in the right-hand table, even though it doesn't have a corresponding row in the left-hand table. The items that we get from the left-hand table, the order ID and the number sold, are both blank because we don't have any information for those 2 columns. The final join type we're going to cover, a full join, includes all the rows from the left table and all the rows from the right table, regardless of whether they have corresponding rows in each table. Let's take a look at what that looks like in practice. In this example, you can see that every product ID has a row in our final table, but for product ID 106, the product name and the price column are blank because product ID 106 only exists in the left table. Product ID 104 only exists in the right table, so the order ID and the number column are blank, but the product name and the price are both filled in. Full joins seem like a great solution to make sure that you're including all the data, but you do have to be careful because if you name things in an unusual way, then sometimes you can end up with duplicate rows in a full join, whereas you would end up with only single rows in a right join or a left join. Picking the type of join is important to make sure that you get the data that you're expecting out of the far side of your query. So I have two different examples of join queries here for us to take a look at. This first one uses an explicit inner join. The second one's kind of a shorthand for an inner join. We'll get to that one in a second. First of all, let's talk a little bit about the query itself. I've added two different fields from the users table, which has a lot of information about the different user, and we're combining that with the same post score and post count that we were using in the previous example. Now, you can see that because we have to pull from two different tables, we have to pick a left table and a right table, as we were discussing. The left table is the posts table, and the right table is the users table. That's just the way I've set it up for now. And we're going to continue limiting the users to just the user with the user ID 42. Two things to note. The first one is that because we now have two tables instead of one table, we've added the table that each field comes from in front of the field name itself. So this is the display name column and it's coming from the users table. This is the reputation column coming from the users table. This is the score column, which is coming from the posts table. You may see aliases for this. So you could say from posts as A, and then instead of posts, we could replace that with A. What that means is that A is just referring to the posts table. So this really means the same thing as this, just without the alias. When we get into the join here, the easiest way to think of this is we're selecting from posts as our primary table, and then we're setting up an inner join. This is the table that we're joining, and then we use an on statement. So we're joining this on this field being equal to this field. So users.id, that's the user ID. And then posts.owner user ID, that's the owner user ID in the posts table. Now, these two match. To find out which fields match and which fields tie together, you can go to the database documentation. We'll get into that in a little bit. That's where I discovered these linkages. But when we run this, you'll see that we get a display name, we get the reputation, we get the score, and then we get the aggregate of our post count. Now, this display name and this reputation are coming from our users table, and the score and the post count are coming from the posts table. Let's take a look at this second example, because this is doing the same thing, but in a slightly different way. I'm going to go ahead and comment this one out. I'm going to remove the comments from our second table here. Now you'll see that we're doing the same thing with our select fields here. We're referencing the table in front of each column name that we want to pull through. The thing that we're doing differently is that instead of having an explicit inner join, like we do up here, we just have from posts, comma, users. So this is our left table and this is our right table. And then in our where clause, we have posts.userid equals user ID, users.id. So what's happening is that this is our join criteria. So what we have in the on statement right here. And then these are the two tables that we're pulling from. We also have our user ID filter still on. So if we want multiple things in the where, we just have where this and this. Same in the on. If we wanted to have multiple parts to this on statement, we could have on this and something else. And you'll see when we run this, it comes out exactly the same as the other query. This is just a shorthand way of writing that inner join. If we wanted to do a left join or a right join or a full join instead of an inner join, what we do is we would just replace inner here with left, with right, with full, and those would join those two things together. Those aren't going to make a difference in this particular case because there's only one match between the two tables. We're not missing anything from the right-hand table when we do the inner join to the left-hand table, but they may be useful for you in other situations. So this is the join query that we just walked through, and I wanted to give you a little bit of an insight into how I was able to find the relationships between the table. If you go over here to this database schema line, you'll see this question mark up at the top here, and if you click on that, it takes you to the documentation for the database. Now, this has a list of the tables along with all of the column names and what a lot of the posts mean, and if that post has some categorical data in it, it will detail out what the categorical data means, what each category means. It also has this picture of the database itself, and all of the fields that join together are linked together using these lines, either the solid line or the dotted line. So we use the users table up here in the top left and the posts table right here in the middle. The user ID in this table right here joins, if we follow this dotted line all the way down, to the owner user ID and the last editor user ID in the posts table. And that's what I used to find the relationship that we used in this query right here. So that's a pretty comprehensive view of the SQL basics in about 20 minutes. Now, the key, of course, is to make sure that you practice this. You can look at the database documentation to practice joining things together, find fields to aggregate, and I'm going to show you in a different video a way you can find a huge number of business questions you can answer with this database. So stay tuned for that. I really do hope you've enjoyed the video. If you found it helpful, please do click the like button and subscribe to the channel. We talk about SQL as well as Power BI, Tableau, and all sorts of other analyst tips. I look forward to seeing you next time.